9. Ignition sequence.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
One small step for man, one giant leap for mankind.
1, 0, and liftoff.
Mission complete, Houston. After serving the world for over 30 years, the space shuttle's earned its place in history and it's come to a final stop.
Good day and welcome to Mission Control Houston, where an expert team of flight controllers is watching over the systems aboard the International Space Station as the Expedition 34 crew continues through its busy day of primarily scientific research, but with some routine maintenance thrown into the mix. On board, Commander Kevin Ford continues his work with fellow NASA astronaut Tom Marshburn and Canadian Space Agency astronaut Chris Hadfield, along with Russian cosmonauts Roman Romanenko, Evgeny Tarelkin, and Oleg Novitsky. Today, the crew is working on experiments that study how liquids and magnetic suspended solids might be used as smart fluids for mechanical systems like brakes and earthquake protection devices. They're also looking at a student experiment that lets middle schoolers guide a digital camera for photos of the Earth below, and another educational activity to let Japanese students vote for and suggest physical tasks for astronauts to demonstrate on orbit that show the difference between microgravity and one gravity of Earth. Kevin Ford tightened down some set screws on the amine swing bed experiment today to try to improve its functionality. Researchers are evaluating how well the experimental vacuum register generated amine system can effectively remove carbon dioxide, looking toward future space vehicles. So far, they've had some resistance to an important valve moving completely. The hope was that adjusting the set screws would allow the valve to move freely, but early results show the adjustment didn't solve the issue. Ford also did some transfer work of recycled water from the water recovery system to use on the station and collected trash to go in the Progress 49 spacecraft before it departs on February the 9th. Chris Hadfield worked with the colloid experiment that works with solids suspended in fluids. It's called the Investigating the Structure of Paramagnetic Aggregates from Colloidal Emulsions 3, or InSpace 3 experiment. Researchers at the University of Delaware are obtaining data on magnetorheological fluids, those that change properties in response to magnetic fields. Tom Marshburn worked with the setup and activation of the iServe investigation. That's a joint NASA and U.S. aid program to document Earth disasters from the station's unique location on orbit. He also worked to do some experiment demonstrations for the Japanese Tri-Zero-G experiment and took measurements of noise levels in the complex with the sound level meter. Meanwhile, the Russians, Novitsky, Tarelkin, and Romanenko also worked on a variety of experiments as well as station maintenance activities. Romanenko worked on packing Progress 49 for its departure and on an experiment that looks at how the heart and bloodstream are affected by life in space. Tarelkin worked with the relaxation experiment that makes ultraviolet spectrometer observations of the chemiluminescent reactions in the xenon plasma outside the space station from firings of 2 plasma contactor units. He talked with experts in Moscow about the installation of data gathering equipment for that experiment. Novitsky worked on routine maintenance in the Zarya cargo module, the first module to launch to the space station, and did some Russian life support system maintenance. Meanwhile, outside the space station, the robotics flight controllers in Houston, backed up by their Canadian counterparts near Montreal and Saint-Hubert, have been used in Canadarm2 and the Dexter fine manipulator system throughout the week to move spare equipment replacement units around. Slow but deliberate work by the Robos this week so far has moved a failed main bus switching unit from its temporary stowage location on external storage platform 2, which is outside the Quest airlock, over to external logistics carrier 2 on the starboard truss, and a transfer of a cargo transport container from external logistics carrier 2 over to Dexter's temporary equipment holder. Later today, they're going to be moving a direct current switching unit component electrical system from external storage platform 2 to external logistics carrier 2. And then tomorrow, they'll stow Dexter on its mobile servicing system that runs up and down the railway along the length of the truss structure so that the robot arm can reach any component it needs to be used to help maintain.
Hi, Chris. We're so proud of you, and we're following your adventures there. I hope Eddie is on his best behavior and his snoring isn't keeping you awake too much at night?
Eddie, lions make a lot of noise when they snore, but we've been keeping Eddie inside a container, inside a cupboard, so his snores have been muffled. But he rode up to space with me, and he's been flying in space the whole time with me, Your Excellency. Thank you for giving him to me.
Chris, be careful he doesn't sneak out of that cupboard. He's quite an adventurer, as you know. We got a whole bunch of great students here for some questions. Let's get on with them.
Yes. We have a first question here for you.
Hello, my name is Emily Zhu, and I'm in grade 6. I heard that your sense of taste gets weaker in space. Is that true?
Emily, your sense of taste, it's sort of like when you have a cold. And when you have a cold, all of the stuff that normally drains out of your nose gets plugged up there. And part of your taste is from your tongue and your smell and your senses. And when you can't smell, your food is hard to taste. It's the same for astronauts, because when we get to space, there's no gravity to pull all the stuff out of our head. And so we get sort of a swollen head, and it fills up our nose and makes our tongue kind of swollen, and you can't taste your food. But after a week or so, your body gets used to it, your nose opens up again, and you can taste your food okay. But for the first week, it's like having a cold, and nothing tastes very strong or nothing tastes very good.
Another question.
Hi, my name's Connell Sloan from Corpus Christi School in grade 6, and I was wondering what would happen if you put a marshmallow outside the space station.
Well, you can see right through that window there, that's outside the space station. There's just a couple layers of glass between us and what is out there, which is the vacuum of space. There's no air. It's completely empty. And in the sun, in the shiny part, it's 150 degrees. And in the shade, it's minus 120 degrees. So let's take your marshmallow and take it outside. Well, first, there's no pressure. And in a marshmallow, there's all that sort of air pockets all trapped in there. That's what makes it all spongy. So your marshmallow would swell right up. And then if it went outside in the dark, if we were behind the Earth, your marshmallow would swell up and freeze. And so you'd have like a marshmallow snowball. And if your marshmallow was in the sun, if you went out on the sunny side, it would swell up and get all gooey. Not like roasting a marshmallow, but you'd have a big gooey mass of a marshmallow, sort of like a big eyeball or something. So marshmallows wouldn't be very good on the outside of the spaceship. But if we had a marshmallow on the inside of the spaceship, I'd eat it.
Hi, I'm Madeline Kushner from Corpus Christi in grade 6, and my question is, you have been experiencing weightlessness for much longer than you have in your previous trips into space. Do you find there's a difference?
Madeline, the big difference this time is I'm used to it. I can fly. I can go all different directions. I can do whatever I want. It's wonderful being in weightlessness this time. I'm fully adapted to it. I don't just feel like a visitor here now. I feel like a spaceling. I mean, it's wonderful to get completely used to being weightless, to have your body used to it. I exercise 2 hours every day to keep myself strong, but my body loves being in weightlessness. It's wonderful to be able to fly and float and watch this microphone. To just be able to float things to each other through space, it's like magic. And to be able to be here for that magic for 5 months is a tremendous gift. I love it.
Hi, my name is Nicholas Yankovic from Corpus Christi School in grade 6. My question is, how do you wash your hands with soap and water in space?
How do we wash our hands? Nicholas, I brought something to answer your question. Look closely at the camera. You can see this. It is no rinse body bath. No rinse body bath. And it's a bag with a straw. So now let's demonstrate. Okay, it's time to get clean. I'm going to squirt some water out. So we have a big ball of water, and you put it on your hand. And now I've got water floating around on my hand. And so I'd wash my hands up with that. And then grab a towel. And dry them off. So that's how we do it. We use no rinse. It's a special type of slightly soapy water, so you don't need to have a bunch of fresh water afterwards. You squirt it, you float a ball of water in front of yourself, and then you just dry your towel. And when you're done, we just tuck our towel somewhere to let it air dry so that the evaporated water gets back into the space station and we can use that water again. So it works pretty well. Sort of like, maybe sort of like if you were on a sailboat and you needed to get clean, you do it sort of the same way.
Hello, my name is Melissa, and I'm in grade 6. And I would like to know, is being in zero gravity like swimming underwater?
Yeah, it's sort of like swimming. Next time you're in a swimming pool, if you got a nice indoor pool there somewhere in Ottawa that you go to, or in the summertime when you're in a lake or a river, try getting out in the water and completely relaxing every muscle. Relax every muscle in your body like I am right here. And if you look at my arms aren't down by my sides like on Earth. My arms float up. And they sort of the same as water because there's no gravity pulling them down. And your whole body's like that. My knees come up. Even my shirt floats up around me. So it's more like floating in water all the time, not swimming in water, because you can't pull against the air. It doesn't, I'll show you, it won't take me anywhere. It doesn't, I just stand here because the air is not as thick as water. So, so it's more like just floating in water forever. It's a beautiful freedom. It's lovely to be able to just float around. So try it next time you're in a pool.
Hi, my name is Owen, and I'm in grade 6. And I was wondering, what would happen if you tried to paint something in zero gravity?
Tried to paint something in zero gravity. Well, we do a little bit of art up here, but we don't have paints because most paints have a smell to them. You know, when you open a can of paint, it's got that strong smell. And on Earth, you know, paint fumes, you don't want to be locked in a small room spray painting because the fumes get really strong. Well, the space station is closed. Every smell that's in here, there's no place for it to go. There's no way for it to get processed except by my lungs or maybe by the equipment. So most paints wouldn't be a good thing up here just because of the strong smell that they have and the chemicals that would come out of them. But I think a little bit of painting would be nice. We have artists who are astronauts who can draw and color, and use charcoal. So I think a little bit of painting would be good, but everything comes up here pre-painted.
Hi, my name is Tom Lane, and I'm in grade 6. I'm wondering, how long did it take to build the International Space Station?
Tom, the space station is big. I wish I could show you it all. It's huge. It's the size of 5 hockey rinks. It's very big. And each piece came up one at a time, and we put them all together. The Canadarm, our big robot arm, reached out and grabbed each piece and attached it as we built the station and made it bigger and bigger. And the very first piece came up 15 years ago in 1998. I was working down in Mission Control that day, and we've slowly built it. I helped build it back on my first flight up here back 12 years ago. People started living here, I think, 12 years ago, and I'm on Expedition 35, so we've had people living here for a long time, and we're still adding to it. There's still pieces coming up. I think you read maybe this week that there's a module that's inflatable that we're going to bring up in a couple years, and the Russians still have a laboratory to come up. So it's slowly getting built. It's like a city that you can never really say it's finished. It started a long time ago, and we slowly add to it and make it bigger and more capable. And right now it is the biggest, most powerful, most capable human building laboratory in space that humanity has ever built.
Hi, I'm Luke Jeeves, and I'm in grade 6, and I was wondering what happens when you sneeze in space.
What happens when we sneeze in space? Well, let's try. Okay, I'll get myself set. I'm going to sneeze. Let's see what happens. Let me get stable. Okay, I'm going to turn sideways to see what happens. Here we go. Nothing. Oh, maybe I'm rotating a tiny bit. So when you sneeze, of course, your body is trying to get something out of your nose, and it pushes it out pretty fast. So that little bit of stuff pushing out of your nose would push you back very slightly. But you have a lot of mass, and the stuff coming out of your nose just has a tiny bit of mass, so it doesn't move you very much. So not much, but also in space, we cover our noses when we sneeze.
Bonjour, je m'appelle Yosri et je suis en 5e année. La question que je veux vous poser, c'est comment dort-on dans l'espace?
Je dors très bien, merci. C'est un peu différent parce que dans le pesanteur, sans gravité, c'est pas nécessaire d'avoir un lit. Donc, j'ai seulement un sac de couchage fixé, branché à la mur. Et je n'ai pas besoin d'un oreiller parce que la tête ne tombe pas. Je flotte. Et donc, pour dormir, je juste utiliser le sac de couchage, flotter à côté de la mur, brancher un peu avec le velcro sur le mur et relaxer et dormir. C'est très confortable. Je pense que c'est beaucoup plus confortable de dormir sur Terre, dans la gravité, sous la gravité.
Hi, my name is Graciela Penafather Moreno, and I'm in grade 5. Why does the International Space Station travel so fast?
Why do we travel so fast? We stay in space because we're going fast. We're going around the moon, or I'm sorry, we're going around the world like the moon goes around the world. And let me explain it like this. If you went outside of the museum that you're in on the roof and jumped off the roof, gravity would pull you right down and you'd get hurt. If you ran right across the roof really fast, run all the way across the roof and jumped off, you'd go quite a ways, but you'd still fall and hit the ground. Well, imagine if you could go across that roof so fast, that you, as you fell, as you came off the roof, the earth curved underneath you, so that you were falling, but you were going so fast that the earth was curving away from you, so you never actually hit the ground. You just kept falling, and the earth kept curving. You have to go really fast, 8 kilometers a second, 28,000 kilometers an hour. But if you can get yourself going 500 kilometers a minute, then you will be weightless because you'll fall at exactly the same speed that the Earth curves. And that's why the space station has to go so fast to stay in orbit and to stay weightless.
Bonjour, mon nom est Ellie Fitzgerald dans la 5e année. Mon question est quel genre de nourriture est-ce que les astronautes mangent?
La nourriture. Nous avons beaucoup de types différents de nourriture ici, mais c'est pas frais, c'est pas la nourriture comme chez vous. La nourriture sèche, on manque un réfrigérateur, pas de congélateur ici dans la station pour la nourriture. Donc, la nourriture sur la semblette, c'est le fruit séché. Je peux l'ouvrir, juste un moment. Le microphone flotte aussi. Donc, ça c'est quoi les pêches? C'est la nourriture de l'espace. Et c'est pas pire. Et aussi, comme ça, c'est quoi? C'est le sudak. C'est de Russie. C'est comme le saumon. Et ça ressemble comme sur Terre, avec les légumes. Donc, c'est pas tellement délicieux, mais c'est assez bien. Et c'est pas le maman qui a préparé la nourriture. C'est pas comme dans un restaurant, mais c'est assez bien pour la santé. Et pour la santé des astronautes, pour moi, c'est parfait.
Hi, my name is Katrina Lane, and I'm in grade 6. My question is, what does the space station smell like?
What does it smell like? It doesn't really have a strong, distinctive smell. It's not a bad smell at all. It maybe smells like being in an airplane. If you go on to Air Canada or something and you walk onto the airplane, it's maybe got a slightly distinctive smell, but it's pretty clean. And we clean every Saturday I clean this whole laboratory. We're inside the Japanese laboratory. I go through and I wipe down every handrail with disinfectant wipes, with wet wipes, and I vacuum all of the filters. So we really work hard to keep it clean. And so it really doesn't have any bad. It's like being in a big building or maybe a nice clean hospital building or something. We work hard to keep it smelling good and healthy. It's good for our health and doesn't let any bacteria grow. And it's better if it doesn't have a smell that you don't like.
Hi, my name is David Greenwood, and I'm in grade 6, and I was wondering about how much space junk is there in the Earth's atmosphere that you can see from the space station?
All space is full of junk or debris. The Earth gets hit by 100 tons a day of space debris. 100 tons a day hits our Earth. Every time you see a shooting star, or a meteorite or something, those are bits of debris coming from the universe. 100 tons a day. Some of it is human-made, only a little bit, but there is some. And from the space station, though, everything's going really, really fast. We are going 5 miles a second, 8 kilometers a second. So all the debris is going faster than a bullet. So you can't see it normally. The only time I've ever seen space debris is when it burned up in the atmosphere underneath me, and I watched a meteorite burn up in the atmosphere. And that was kind of a spooky feeling, because that meteorite could have hit us and not just been caught by the Earth's gravity into the atmosphere. But even though we know there's some around, space is big, and we get peppered by tiny bits all the time. But the space station's a good ship, big, strong ship, and so far, so good.
Hello, I'm Sam Lyon, grade 6, and I was wondering if you play any games in space that you can't play with gravity, or games that become more difficult or fun without in zero G.
Yeah, this is a great place for games. You would love it here. Imagine playing, hide and go seek up here, where you could float into any cupboard. You could hide up in the ceiling or in any sort of corner. So it's a great place for that. But we don't play hide and go seek very often. We're playing a game of Scrabble right now, but Scrabble's pretty hard without gravity, because your pieces float all over. So we have a Scrabble game where the pieces sort of click into place, and our board is up on the ceiling. You could play darts here, but you wouldn't want pointy darts because we're inside a spaceship. But if your dart just had a big lump on the end with Velcro, and you threw it nice and slowly, maybe with big feathers on the end, then you could play darts. But when you throw darts on Earth, gravity pulls them, so they curve as you throw them. Here, they would go straight. You could throw your dart, and it would go absolutely straight all the way to the target because there wouldn't be a curve of gravity. So I think, this would be a fun place to figure out how to play a bunch of games. And we play a little in our spare time, but mostly we're here to work. And so we don't experiment like you would if you just actually lived here as a regular person.
Hi, my name is Niket. I'm in grade 6. I just want to know who or what inspired you to be an astronaut.
Well, you're in grade 6, so you're probably about 10 or 11, maybe 12 years old, probably 10 or 11. And, you've probably heard of some people that have done really interesting things in their life. Someone who's done something that you think, wow, that's cool. Or you've seen someone do something and you think, oh, that's not good. Well, you're going to grow up to be one of those people. You're going to grow up to be somebody, and you're going to do something when you get to be an adult. And when I was your age, I looked at what some of the people were doing, and I watched the very first people walk on the moon. The very first 2 human beings walked on the moon when I was 10 years old, almost 10. This summer I turned 10. And that's what inspired me. I just thought, I'm going to grow up to be something. Why don't I grow up to be that? That looks like an interesting thing to do. And I knew it probably was impossible, but I thought if I don't try, it's definitely going to be impossible. And even if I don't get to fly in space, all those things of learning to fly and build spaceships and how to make machinery and how to test things and all about navigation, about geology and geography, it's all interesting. And so I was inspired to become an astronaut by 2 of the very first explorers, the first 2 people to walk on the moon.
Chris, this was our last question, but maybe His Excellency wants to add a few words.
Well, Chris, thank you so much. Thanks for those wonderful explanations to the great questions from the students here. Keep the amazing photos coming from space, and you're a wonderful ambassador for Canada and for the whole world. Be sure that Eddie stays on best behavior and keeps his notes, because when you and he come back, we're looking for some tremendous stories. Thanks, Chris. Bravo.
Thanks, Chris. Thanks, His Excellency. Thank you so much. Merci.
Merci à tout le monde. Thank you very much, Your Excellency. It's a privilege to talk to you and a delight to talk to young Canadians in Ottawa today. Thank you for having me there. And I got to get back to work. But it's a great museum. There's a lot of Canadian history there. Enjoy your time. And nice to see you all. I will take care of Eddie for sure. Bye now.
This is Atlas Launch Control at T-minus 1 hour, 56 minutes, 50 seconds and counting, where we have received a go to move into the cryogenic tanking process of our Atlas V rocket, beginning the chill down process to condition all the lines through which the cryogenic propellants will be flowing. Right now we have joining us Badri Yunus, the Deputy Associate Administrator for Space Communications and Navigation at NASA headquarters. And we've asked Badri to sort of set the stage a bit for us here if you can, because the evolution of spaceflight tracking really goes way, way back and brings us to sort of a very current state-of-the-art, which is completely different technology than what we began with, say, in the Mercury program. So, Badri, we're going to roll this tape, and if you can tell us a little bit about the history and then lead us into TDRS.
Definitely.
Roll the tape.
Are we on the air? Okay. In the 70s, prior to the TDRS, NASA relied on a number of ground stations distributed worldwide, and still, we needed a number of ships and number of airplanes to provide some coverage to our mission, in particular to our human flight missions. Even with that, over 20-some ground station and about 5 aerial and 5 naval ships, we couldn't provide more than 15% coverage. So the concept for the space network, in particular for the TDRS constellation, came at that time. We needed something that can provide us much better coverage and also get us out of these not so secure places on Earth. Definitely, our location on Earth depended to a large extent on the political situation in that country. They could get us out anytime. There were certain locations that were not safe, and we had to send our engineers and our operators over there. So it took some time for the concept to evolve into the TDRS constellation and the space network that we know. It started with our launch of the first TDRS in the early 80s, 2003, to be precise. So it has been 20 years, and the space network hasn't stopped to provide the kind of critical support to all of NASA, be that human space flight and other science mission, for anything that orbits the Earth between the surface of the Earth and the geostationary orbit. The support that it provides is extremely critical. It provides, an open kind of continuous data channel between the user in space and the ground, and vice versa.
So at this point, when we look farther out, it would appear, based on the success of the TDRS network, that space-based tracking is really sort of here to stay. And can you kind of look a little bit into the future?
Oh, definitely. The TDRS experience and the space network experience have demonstrated that the services provided by TDRS are unmatched. There are no other systems, and there is no other way. Actually, there are no alternatives to TDRS. The cost is definitely much lower than we would have to pay had there been an alternative, but there are no alternatives. We have looked at other systems, other space systems providing communication support to commercial services, but they could not do what TDRS is doing. TDRS is, designed to support anything in space, while the other systems are designed to support the ground, users. So the market is different. So with this TDRS-K, we are introducing the first of 3 satellites, the 3rd generation tracking and data relay satellite systems. And we are introducing these 3 satellites to replenish the constellation that we have. It has been 10 years since we flew the last, or since we launched the last of the 2nd generation TDRSs. This particular effort has been more than 8 years in the making. Dedicated effort by the SCAN team, in particular by our folks at Goddard Space Flight Center, be that the engineers and the managers and the support personnel there, as well as the entire SCAN team. So really today we are all looking forward to a successful launch. Definitely, the space network is not only important to NASA, it's important to the country as a whole. It's a national asset. It has provided support to other NASA users. We have supported NOAA, NSF, and many other agencies. Again, the kind of capabilities we have are unmatched. The cost is pretty low compared to other means, and it's definitely a very reliable system.
Well, Badri, thank you very much. And of course, we're looking forward to a February launch tonight, as I'm sure everyone on the system
Before
is.
leaving the air, it's really rocket science. I'm always impressed by the level of complexity that such an effort takes. But the kind of people that we have in here, from the Boeing, the manufacturer of the satellite, to the ULA folks in here, who are responsible for the Atlas V, to working together with our launch service program, as well as the technical folks at Goddard Space Flight Center, who are managing and operating the space network, and they did manage the development activities of the of the TDRS has been awesome. We have a very cohesive team. We have a superb team. We really, you look at NASA at its best, you know, where the can-do attitude is prevailing. Hopefully we'll have a successful launch. We are extremely looking forward to its, completion.
Badri, thank you very much, and we're looking forward to the liftoff as well. It looks like fueling's underway, so we're on the right track. Thank you very much. We're at T-minus 1 hour, 49 minutes, 33 seconds, and counting. This is Atlas Launch Control.
Payload and CEM ECS have been on GN2 for 40 minutes minimum. Roger.
This is Atlas Launch Control at T-minus 1 hour, 43 minutes, 18 seconds, and counting. Loading of the Centaur stage with liquid oxygen now underway. We'll look briefly at some video of the rollout taken yesterday at about 10 o'clock in the morning of the Atlas V with Teachers K going to the launch pad. We have an unusually large fairing on top of the Atlas V this time. It's a 14-foot fairing. Our total length of the vehicle there, as we see it, is 192 feet. The RP1 fuel, which is a highly refined kerosene, was loaded aboard yesterday afternoon at around 2 o'clock. And it is holding 25,540 gallons of RP1. The liquid oxygen on the Centaur, which is being loaded on board now, amounts to about 4,150 gallons. Altogether, it took about a half hour to get from the vertical integration facility out to the launch pad at Space Launch Complex 41. Once we lift off, the Atlas first stage will burn for about 4 minutes and 2 seconds before the Centaur stage separates and the Centaur ignites. This is a time lapse of the Atlas V going out to the pad. This is Atlas Launch Control, T-minus 1 hour, 23 minutes, 53 seconds and counting. 75% of liquid oxygen on board the Atlas stage, as we just heard. And joining us now here at the Public Affairs Console in the Atlas Launch Control Center is Jeff Gramling. He is the project manager for TDRS K, and Jeff, would like to welcome you very much, and hopefully you've had an uneventful countdown up to this point. Is the spacecraft exactly where it should be at this point of the count?
Yes, George, we're all very happy. Everything so far is looking very good. We haven't seen any problems, and we're ready to launch tonight.
Well, we've got some video of what your processing flow looked like from when you arrived right up to going up out to meet the Atlas V. So if we could roll the tape, and Jeffrey, if you could tell us what we're seeing.
Sure. Well, what you see here, George, is we flew in a C-17 from the Boeing plant in El Segundo, California, from Los Angeles International to the shuttle landing strip on Kennedy Space Center. And what you see here is the payload container being offloaded from the C-17, and from the shuttle landing strip it was transported over to Astrotech in Titusville, where we did spacecraft processing for a few weeks.
And the spacecraft came in from where?
The Boeing facility in El Segundo, California, so the C-17 actually took off right across the street from the plant from Los Angeles Air Force Base and then flew to Kennedy. And you see it's a rather large container. Of course, the spacecraft in that container is in the horizontal position with everything stowed as it would be in the payload fairing for launch. And here you can see it arriving at the Astrotech facility in Titusville. And that's a very large high bay, so we can do our spacecraft processing that has to happen before we encapsulate in the Atlas fairing, which you'll see coming up here.
Altogether, the total amount of time you were out at Astrotech from the time you arrived until rollout was about how long?
Well, we landed at Kennedy on December 18th, and then because of the holidays, we did some testing before the holidays, and then we stood down for a week or so. And then we left Astrotech a week and a half ago, so we were there for 2 or 3 weeks. And you can see here the container being opened up, and there you see the spacecraft bagged for shipping. And you can see the single access antenna reflectors sticking out of the bag there. And here's the technicians unbagging the spacecraft to protect it during shipping. And what you see here is it being placed on a test fixture in one of the high bays at Astrotech.
So then there's a series of electrical tests, I gather, before you start to fuel.
Right, several electrical tests to make sure that the spacecraft is functional. We do the tests that we can do. Obviously, we can't do all of the testing that we could have done in the Boeing plant in El Segundo, but we do enough to make us comfortable the spacecraft has survived shipment and we're ready to launch. So here you can see the spacecraft is still basically in the launch configuration with the single axis reflectors stowed, or in this case they're furled around one another, with solar wings folded there against the body on 2 sides with the outer panel exposed so that in transfer orbit, as we're spinning, we can get power. And what you see here are the 2 halves of the Atlas fairing being maneuvered around the spacecraft. And you can see, George, here that the TDRS spacecraft does a pretty good job of filling that extended Atlas fairing that we use. And at this point, we're encapsulated, and what you'll see coming up is the spacecraft being and the fairing placed on a truck and being driven over to the vertical integration facility on Launch Complex 41, and that happened at about 2 in the morning a week and a half ago.
So once you get out to the pad, then you're ready to mate to the rocket and get ready to fly.
Right. So once we got out to the pad, obviously, then in the vertical integration facility, we were lifted up and stacked on top of the Atlas Centaur. And of course, the picture you're seeing right now is after we've rolled out to the pad, obviously. That was yesterday morning. I think this must be a current picture here. It's in the evening.
Now tell us a little bit after the spacecraft comes off the rocket later tonight. What are the things that are going to happen right away, and what are the things that will happen a little bit later on? What are the milestones?
So right after we launch, an hour and 40 minutes or so after that, we'll actually separate from the Centaur upper stage, and after that we should be seeing telemetry signal from the satellite through the USN tracking network. Some period of time later, I think it's on the order of an hour or so, a couple hours maybe, the only deployment we do before we get to GEO is we unfurl the single axis reflectors, and then it takes about 10 days for us to get from our geosynchronous transfer orbit that the Centaur leaves us in until we use an internal engine to get up to our geosynchronous altitude. In other words, we've circularized our orbit. That whole period is controlled out of the Boeing Mission Control Center in El Segundo, California. Once we get to GEO, we would finish all of our deployments, unfurl the solar wings, deploy the single-axis antenna booms, and once we've done that, then we would hand over to the White Sands ground station in New Mexico, which is our ground station, and from there on we'd undergo about 3 months of calibration and on-orbit testing before we would drift the spacecraft to its operational location.
And again, it's about how many days before, after launch until you're up actually at the geosynchronous altitude?
It's about 10 days.
About 10 days, okay. All right. So at that point, you'll be doing the checkout, and when that's complete after 3 months or so, where will the spacecraft move to, or will it stay pretty much where it's at?
When we launch, we go to 149.8, I believe it is, west longitude. Once we're finished on-orbit checkout and testing, then I believe the plan is to drift it to 171 degrees west, where we would continue testing with more users that are actually flying to gain confidence, and then a decision will be made, whether to keep it in service or to put it in the storage, depending on the health of the other spacecraft in the fleet.
All right. Well, are you actually working the next TDRS spacecraft coming up in a year or so?
I am. My project is in this is the first one. We started this about 6 years ago. TDRS K we're launching today. TDRS L will be going into storage. We'll finish testing here in a couple months. It will go into storage, and right now the plan is to launch next January. So we'll be back here in a year, and we're looking forward to that. And then TDRS M will be ready to launch in December of 2015. So we've got our hands full. In parallel with this launch activity, we're also completing testing of TDRS L on the high bay back at Boeing.
Well, Jeffrey, thanks very much, and best of luck to you and the Goddard team as well as the Boeing team, and we'll look forward to seeing this in its initial orbit later tonight.
Okay, thank you, George.
Thank you very much. We're now at T-minus 1 hour, 14 minutes, 49 seconds, and counting. This is Atlas Launch Control. This is Atlas Launch Control at T-minus 1 hour, 9 minutes, 30 seconds, and counting. Joining us now is Diana Calero. She is the mission manager for the Launch Services Program here at Kennedy Space Center for the TDRS K mission. Diana, welcome, and we would really like, if you would, we've got a video of the entire processing of our Atlas V. It includes going up on top of the rocket, and if you could tell us a little bit about what we're seeing as we go along.
Sure, no problem, George. Right now we're seeing the Antonov aircraft landing at the Cape here with the Atlas V booster, and that arrived on November 5th, and it was transported from Decatur, Alabama, where it's manufactured. And you can see them offloading the booster here. Booster's about 106.5 inches long, 106.5 feet long, and 12.5 feet in diameter. And you see that being covered there. It's really an incredible sight to see how long and how big that booster is. So it's getting loaded onto a transporter. And right now it's making its way to the Atlas Spaceflight Operations Center, or ASOC, where it's going to go through its receiving inspections and go on to some initial power-on checks before it begins to get mated to the other parts of the rocket. So once out of the ASOC, it's transported out to the Vertical Integration Facility, or VIF. And there you'll see they start placing it into a vertical position, and it'll begin its hoist up into the VIF. And the VIF is about 280 feet tall. It's quite large, and this is a 401 vehicle, so it's not their largest vehicle. So there's plenty of room there, and once it's placed on the mobile launch platform, as you can see there inside the VIF, it's going to await the other parts of the vehicle to get mated. After the booster is mated there, the interstage adapter will be mounted on top. There's a good shot of the RD Amros RD-180 engines. Those engines are capable of a thrust of 160,000 pounds and about a specific impulse of 335 seconds. And what we're seeing here now is the Mariner ship that is carrying the Centaur. And the Centaur also is coming from Decatur, where it's assembled. And that has a journey through the different rivers. Starts in the Tennessee River, goes to Ohio, and then the Mississippi River, and then comes out the Gulf and around the peninsula and docks here in Port Canaveral. That gets offloaded and transported also to the ASOC, where it does its receiving and checks, initial checks. And once that's ready, it is transported to the VIF and will also be mated to the top of the booster. And what you'll see now is they're placing in a vertical position in preparation for the hoist. You could see the engine on the Centaur's Pratt Whitney Rocketdyne RL-10A engine, and that has about a thrust of 22,000 pounds with the specific impulse of 442 seconds. The Centaur is about 41.5 feet long with a 10-foot diameter, and this Centaur was mounted to the booster. It was mated to the booster on January 5th. And once that gets mounted on there, they start doing some initial checks of the vehicle once the vehicle is actually considered completely assembled, just waiting for the spacecraft. And I'll do a combined systems test to make sure that everything is working properly. And you'll see there's a good shot of the engine going into the interstage adapter, which protects the engine once it's mounted. And so now we're just waiting here for the encapsulated spacecraft. There's a nice view of the hand-painted logo on the payload fairing. And so this gets transported in the middle of the night. It's about a 25-mile journey from the Astrotech processing facility. And it gets hoisted and mated on top of the Centaur. And that mate happened on the 19th of January, and there you see the whole rocket being ready for a launch.
Well, Diana, tell us a little bit your role as the mission manager for Launch Services Program. What is your role with the spacecraft, and when did you become involved with TGS-K?
Well, LSP actually gets involved with the spacecraft about 3 or 4 years ahead, and you start planning for all the requirements they're going to need to interface with the rocket. And so you make your initial requirements and you gather them in preparation to acquire a launch service. And that's where we step in and we acquire that launch service, and in this case it was the ULA Atlas V. And so that happened about in 2008. I actually got involved with TGS-K about a year ago when I inherited the mission from a former mission manager. So I've been involved with TGS-K NL for about a year now. So
are you also working the next TGS coming up in about a year or so, TGS-L?
Yes, I am, yeah.
So, so just like Jeff Gramley, you're rolling right out of one and into the next one, even though it's a year away.
Yeah, there's not much pause in between the two missions, so we finish off one and we're going into some operations on L already. So.
Well, Diana, thank you very much for coming by and showing us what we did to get the Atlas built up out of the pad and ready to fly tonight. And best of luck to you and the rest of the Launch Services Program team.
Thank you very much, George.
And we've gotten to go for the chill down for the cryogenic liquid hydrogen that will be flowing into the Centaur stage a little bit later on. We're at T-minus 1 hour, 2 minutes, 10 seconds and counting. This is Atlas Launch Control. This is Atlas Launch Control, T-minus 53 minutes, 24 seconds and counting. Our countdown is proceeding through the steps. We're hearing our United Launch Alliance launch conductor Ed Kidda directing his launch team. Upon liftoff, the tracking of the Atlas V rocket will be done by the Air Force Eastern Range, beginning with the antennas at Cape Canaveral Air Force Station and the Kennedy Space Center. 24 seconds after liftoff, the downrange station near Jupiter Inlet in South Florida will also acquire the rocket. The next station to acquire will be at the island of Antigua in the Caribbean, which will take over immediately prior to loss of signal from Florida. Antigua will supply data until approximately 14 minutes into the flight, at which time data will be coming through the TDRS East tracking and data relay satellite. As the rocket approaches the Indian Ocean, the Air Force tracking stations at Diego Garcia and Guam will also begin covering, right through the spacecraft separation event, which occurs 1 hour 46 minutes after launch. Then once TDRS-K is on its own, having separated from the Atlas V, the initial contact with it will be made through the Dangara tracking station on the coast of Western Australia. At liftoff, if you're following the rocket from the coast and you're wondering what direction it will move, the launch azimuth is 101.4 degrees, just slightly to the south of east. At separation, the orbit of the spacecraft will be an elliptical one, 19,323 miles by 2,328 miles. And as we heard from Jeff Scrambling, the spacecraft over the next 10 days will go all the way up to geosynchronous orbit. And we're at 20% now, 20% level on the Atlas first stage liquid oxygen. Weather continues to be green for a launch tonight. And anything we're behind in the countdown with a couple of anomaly discussions that we've had will easily be made up in the hold, which occurs at 7 o'clock tonight. It will be a 25-minute hold. The clock will go down to T-minus 4 minutes, hold for 25 minutes, and anything still undone that needs to be finished to catch up to resume the count on time at T-minus 4 minutes will be done during that time. We're now at 30% liquid oxygen on the Atlas vehicle. And Centaur LH2 now at 30%. At T-minus 50 minutes and counting, this is Atlas Launch Control. This is Atlas Launch Control, T-minus 26 minutes, 20 seconds and counting. Loading of propellant aboard the Atlas V rocket continues to go smoothly. We will be continuing in the countdown to T-minus 4 minutes, at which point we'll be entering a 25-minute planned built-in hold, which will allow for any catch-up activities that need to be done. We'll also be getting a weather briefing from our Launch Weather Officer Clay Flynn for the 45th Weather Squadron in about 20 minutes from now. Once we come close to releasing the built-in hold at T-minus 4, we'll get a final poll for the NASA launch team from our NASA launch director Tim Dunn, and then the launch director for United Launch Alliance, Ed Kidda, will be polling his team in preparation for continuing the count and picking up for the last 4 minutes. And at this point, we're still targeting an 8:48 p.m. liftoff. At T-minus 25 minutes, 3 seconds and counting, this is Atlas Launch Control.
T-minus 25 minutes.
This is Atlas Launch Control, T-minus 9 minutes, 7 seconds and counting. The next major event will be a weather briefing by our Launch Weather Officer Clay Flynn, which will occur at T-minus 5 minutes. Also, about a minute later, we should be going into our final planned built-in hold. It's a 25-minute hold at T-minus 4 minutes. And after we go into that hold, we'll have Vernon Thorpe from United Launch Alliance come over and go through the flight sequence of what the Atlas V rocket will be doing as it after it lifts off from the pad. At T-minus 8 minutes and counting, this is Atlas Launch Control.
Comes to RF link. Roger.
Elsie, flight control.
Go ahead.
Operation 40, step 1680. Primary adjust, TechX file, adjust, underscore. Alpha, Victor, 036, underscore, 05. With SELCRC, 28 Echo 0. Has been received, verified, and is ready to load into the FTINU.
Proceed with load. Minus 6 minutes. Fuel fill sequence is complete. Roger. LCALO. Go ahead. Atlas fill and drain valve cycle test is complete. Roger. Atlas airborne vet valve functional test complete. Roger. Perform POGO suppressor charge. Roger.
GCQ, flight control.
Net 1. Weather briefing on Channel 8 Weather Conference Net.
Roger. LWO, range coordinator, Channel 8. LWO. Can you stand by for weather brief, please? Standing by. Following personnel, acknowledge standing by for the weather brief. LD. LD. NLM. NLM. AFLD. ALC. ALC. LWO, please proceed with the weather brief. Yes, sir, this is the LWO on Channel 8 Weather Briefing CC Local. Taking a look at the peninsula of Florida there, you can see just very limited cloud cover over the central Florida peninsula. Not looking for any issues with any type of cumulus cloud, rain showers, thunderstorms. We're in favorable weather conditions for the balance of the county and window. And looking at the radar, nothing on the radar, not expecting to see anything on the radar for the balance of the county and window. This is the 1-minute data. Peak winds presently just gusting to 21 knots. We've had as high as 24 and a couple of hits at 24 knots, and we should stay in that range, gusting between 20 to 24 knots through the balance of the county and the window. And generally speaking, in terms of the direction, staying from the south, becoming a little more from 190, presently from about 183 to 186, so a little about 190 for the during the window, I believe. And temperature at the present time is 72 and should drop a degree or two. In terms of the upper air profile, taking a look at, the upper air profile. Winds have increased through the count in this region right in here, and would expect to see a continued gradual increase if we were as we progress through the count and window for the balance of the count and window, approximately 5 to 10 knots. In terms of the ops forecast, looking for favorable conditions with just scattered low and scattered high clouds, 7 miles visibility, winds from the south at 20 gusting 24, no weather, and temperature in the low 70s with a 10% chance of violation. All LCCs are go and expected to remain go. No change in the 24-hour delay forecast. Proton flux remains at normal background levels, and not expecting any lightning, and looking for just gusts to peak gusts to 24 knots to the balance of the count and window, a small threat of exceeding 25 knots, and a smaller threat of exceeding 27 knots. This concludes the weather brief. Pending your questions, sir.
Range coordinator has no questions. LD has no questions. FLD, no questions.
LWO, this is NLM. Do you have the exposure forecast for the morning?
Yes, sir, I do. I apologize. A 10% chance of lightning during the overnight hours, sir. And with that, just with the stronger gradient, if we did get a lightning, I had winds a little elevated for a 38-knot concern if we did get any lightning overnight, sir.
NLM copies, no questions.
This is Atlas Launch Control, T-minus 4 minutes and holding. During the weather briefing, we went into our planned hold at T-minus 4, which is 25 minutes in duration, and we completed the liquid hydrogen loading on board the vehicle. So at this time, we continue with that favorable weather forecast to press on toward an 8:48 p.m. liftoff. At T-minus 4 minutes and holding, this is Atlas Launch Control.
OSM, LC?
OSM.
Verify the FCO, RCO, and OSM hold fire switches are in the proceed position.
Ready to proceed.
This is Atlas Launch Control, T-minus 4 minutes and holding. We're in the middle of a planned 25-minute built-in hold. And we have joining us right now Vern Thorpe from United Launch Alliance. He's the program manager from ULA for NASA missions. Vern, first of all, tell us a little bit how this countdown has been going. It seems like there's been some things that we've had to work, but they all seem to have kind of come out in the wash.
Yeah, we've had a few minor issues. The vehicle's looking healthy, and the weather is cooperating right now. We were a little bit concerned about winds earlier in the count, as you know, but the winds have come down. And we've had a few minor issues on the vehicle, but they've really been in the area of instrumentation type issues. Nothing that would prevent us from launching. So hopefully that will continue.
Well, Vern, we've got some video now that shows us what the Atlas will be doing after liftoff. So If we could go ahead and roll the video, and Vern, tell us what we're seeing.
Okay. This is what the vehicle looks like on the pad tonight. This is an Atlas V 401 configuration. This is footage from a recent launch. At liftoff, the booster engines will be putting out about 900,000 pounds of thrust to get the vehicle off the ground. And since we have no solid rocket boosters on this mission, the first major event that we'll see will happen about 4 minutes into flight. At that point, we will have used up all the propellants in the booster stage, and at that point we will shut down the booster engine. You'll see that here momentarily. And about 6 seconds after we shut down that booster engine, we will send the separation command to separate the booster from the Centaur upper stage. We will then prepare the Centaur engines for the first of 2 burns for this mission. That first burn will last about 14 minutes, and 10 seconds into that first burn, we'll be up out of the atmosphere and we'll jettison the payload fairing, as you saw right there. This 14-minute burn will put us into a highly elliptical orbit. We'll have a perigee of only about 99 nautical miles, but the apogee at that point will be over 13,000 nautical miles. Following that first burn, we'll coast for about 82 minutes. That puts us in position for the second burn that you see right here. That second burn will only last about 1 minute, and that will put us into what we call a geosynchronous transfer orbit. The apogee of that orbit will be up at geosynchronous altitude, which is where the spacecraft will do a series of burns to circularize. After we separate from the spacecraft after that second burn, we'll do a series of maneuvers with the Centaur upper stage to put it into a safe orbit and make sure that there's no possibility of recontact or contamination of the spacecraft.
And then actually what ULA does after the spacecraft is actually on its way, you continue to follow it for some other activities, am I right?
Well, we do a series of maneuvers with the Centaur upper stage, and again, that's to preclude any chance of contaminating or recontacting the spacecraft. Eventually, we'll put it into what's called a safe orbit. It's an orbit that is out of the way, doesn't stand any chance of interfering with the space station or with any other satellites that are up there.
That's where I was going with that question. We're kind of putting it into a safe
yes,
configuration.
The lowest part of that orbit will be above the space station altitude, and it'll be well below the geosynchronous altitude where most of the communication satellites are, and then it'll remain there indefinitely.
Well, Vern, thanks very much, and I guess we're very shortly going to be on the way here, so we will be watching as we get to T0. Everything appears to be on track. The weather looks good, so it looks like TDRS K may be out of here very shortly.
Okay.
Thank you
very
much for coming by.
My pleasure.
Vern Thorpe, the Program Manager for NASA Missions from United Launch Alliance. At T-minus 4 minutes and holding, this is Atlas Launch Control.
Launch on time verified.
Roger.
This is Atlas Launch Control, T-minus 4 minutes and holding. 12 minutes, 23 seconds remaining in this planned built-in hold. Once liftoff occurs, we'll hear the voice of Marty Malinowski from United Launch Alliance. He's our telemetry engineer for the flight. We'll hear him making all of the calls as the Atlas V goes through its various stages initially into the coast phase, and then for the final burn of the Centaur and spacecraft separation. One point of note is that we do have a collision avoidance quotient on the second minute of our window. So right now we are targeting the opening of the window at 8:48, but we would have a cutout there of a minute at 8:49 and then could pick up again at 8:50 should we not get off right at the opening as we're targeting. But as we've just heard, everything is on time right now for an 8:48 p.m. liftoff. At T-minus 4 minutes and holding, this is Atlas Launch Control.
Attention all stations, this is the NLM on the NLM net. We are in good configuration with the launch vehicle. Centaur prop loading is complete. Booster LO2 loading is complete. The range is green. Weather is acceptable at this time. I would now like to conduct the final launch readiness and spacecraft configured for launch poll. NASA CE.
NASA CE, go.
SMA.
SMA's go.
SMD.
SMD's go.
NASA MEM.
NASA MEM is go.
NAM.
NAM's ready.
NLM copies. The NASA team is ready for Teachers K launch.
LCRC1.
Go.
Launch window management plan 0228 Zulu.
Copy.
This is Atlas Launch Control. We have about 4 minutes remaining in this planned built-in hold, and we're at T-minus 4 minutes and holding. Momentarily, we should get a final pole to come out of the hold and continue toward on-time liftoff at 8:48. At T-minus 4 minutes and holding, this is Atlas Launch Control.
Status check to proceed with terminal count. Atlas systems, propulsion, go. Hydraulics, go. Pneumatics,
go.
LO2,
Go.
water.
Go.
Centaur systems, propulsion, go. Pneumatics, go. LO2,
Go.
LH2,
Go.
PASGAS,
Go.
electrical systems, airborne,
Go.
ground,
Go.
facility,
Go.
RFFTS,
Go.
flight control,
Go.
instrumentation,
Go.
comm,
Go.
timer,
Go.
GC cube, go. Umbilicals,
Go.
ECS,
Go.
redline monitor,
Go.
quality,
Go.
ops safety manager,
Go.
ULA safety officer,
Go.
range, weather, and clear to proceed.
Go.
Launch director,
LC, you have permission to launch.
proceeding with the count. T0 is planned for 01:48:00. Set count to start at 01:44:00.
Roger. T0 is set for 0148 Zulu. Count will start at 0144.
LC, this is NSC on countdown 1.
Go ahead.
Spacecraft on internal power.
Roger.
This is Atlas Launch Control, T-minus 4 minutes and holding. 1 minute remaining in this hold. Teachers K is configured for launch. Very quiet here in the Launch Control Center. We're working no issues. "30 seconds to picking up the count. Picking up in 10.
On my mark, time will be T-minus 4 minutes and counting. 3, 2, 1, mark. T-minus 4 minutes and counting.
Ground power is enable.
Final Atlas and Centaur go for launch will be at T-minus 25 seconds. And we'll have engine ignition at T-minus 2.7 seconds.
Minus 315. Minus 3 minutes.
Securing LO2 topping. Atlas tanks to flight pressure.
Minus 250.
FTS internal.
Minus 2 minutes.
Vehicle internal.
155.
Launch sequencer start.
150.
Securing Centaur LH2.
Securing Centaur LO2.
140.
FCS launch enable.
FTS armed.
$120.
Orc is armed.
FCS count started.
115. 110.
Vent valves locked.
Minus 1 minute.
Rock, report range status.
Range green.
Minus 40.
Stable at step 3.
Minus 25.
Status check.
Go Atlas.
Minus
Centaur. Go Teachers K.
T-minus 15 seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And liftoff of the Atlas V rocket with TDRS K, broadening, enhancing, and improving the capability of space-based tracking.
Roll program has begun. Body rates look good. Bus and battery voltages are stable. Booster engine continues to operate well. Pump speeds are within parameters. Boost pump pressures are good. Currently accelerated at 1.4 Gs. Engine operation continues to be excellent. Roll program's complete. Booster PU is now operating in closed loop control. Lock 1. Max Q. Body rates continue to look very good. Booster has throttled back right on schedule. Engine response looks good. Currently accelerating at 1.8 Gs. Current altitude is 13 miles, downrange distance 9.6 miles. Current velocity is 2,390 miles per hour. Booster performance continues to look very good. This phase in flight. Bus and battery voltages are stable. Tank pressures look good. And closed loop steering has been enabled. Small perturbance in body rates, but everything looks very good. Range track right now looks like they're heading right down the middle of the range. And the RCS pyro valve has been fired. That system's now pressurizing up the flight levels. Signatures look good. Booster performance continues to be nominal. And we have ended the Q alpha limited steering. Body rates are good. Bus and battery voltages are stable. Tank pressures are within parameters. Booster engine performance continues to be nominal. Currently accelerating at 4.4 Gs. All systems look very good. And boost phase chill down is underway. Coming up on our 5G throttle segment. We're now throttling to maintain 5 Gs. And now have throttled back to 4.6 Gs. Boost phase cooldown is complete. And we have BECO. Engine shutdown looks good. We have retros and stage separation. We have LOX and fuel pre-start on the Centaur main engine. The RCS GN2 purge firing is underway. We have ignition in RL10 and full thrust. We have payload fairing jettison. Looks like a clean separation. Range track continues to look very good. Current altitude is 96 miles, downrange distance 299 miles, current velocity 11,142 miles per hour. This burn is expected to be just short of 14 minutes in length. Currently, Centaur is commanding the PU to the oxidizer-rich condition as planned for the early portion of this burn. Centaur closed loop steering has been enabled. Propellant tanks have been vented down to the correct levels for this portion of the burn. Current altitude is 108 miles, downrange distance 445 miles, current velocity 11,354 miles per hour. Vehicle body rates look good. And the range track shows Centaur making good headway right down the middle of the range. Centaur PU is now beginning to control off the oxidizer-rich stop. Quick check of the booster performance shows that we were positive 64 pounds in PE, which is 0.65 sigma in performance. We've begun seeing our RCS thermal conditioning firings. Those line temperatures are now warming towards bottle temperature. Our L10 engine performance continues to look good for the mixture issue that is set. And we have had the format change at this point, just a minor dropout in data. Data quality is currently very good. Bus and battery voltages on Centaur are nominal. Current altitude is 148 miles. Downrange distance is 785 miles. Current velocity is 12,041 miles per hour.
And we've had acquisition
Centaur
through
View continues to
anticipating losing the signal from the Cape.
Centaur body rates look good, controlling right down the middle. Range track continues to show good progress towards the head-on gate. Centaur currently is flying at 161 nautical miles in altitude, downrange distance of 1,012 miles. Current velocity is 12,644 miles per hour. And Centaur has passed the head-on gate at this point in the mission. Centaur engine performance continues to look very good. Centaur PU continues to operate slightly oxidizer-rich. Turbine inlet temperature looks appropriate for the set mixture ratio. RCS line temperatures have nearly warmed to bottle temperature and continue to see our thermal conditioning firings. Signatures look good. Bus and battery voltages are stable. This point in the mission, Centaur is currently flying at 190 miles in altitude. Downrange distance is 1,442 miles. Current velocity, 13,945 miles. All systems continue to operate nominally at this point in the mission. And Centaur is currently accelerating at 0.56 Gs, as the PU system is now operating near nominal mixed ratios, having burned off the excess oxidizer.
11 minutes, 30 seconds into the mission. I have data from Antigua until L plus 14 minutes, 15 seconds, at which point the handoff to Tidris East will occur.
Centaur tank pressures continue to look good. Storage bottle pressures are stable. Bus and battery voltages are within expected range. Continue to see our RCS thermal conditioning firings on a regular basis. That system is now operating at nominal temperatures throughout. And the main engine PU setting is basically nominal. Current altitude is 171 miles, downrange position 1,955 miles, velocity 15,700 miles per hour. Yep. 5 minutes remaining in this mission. Shows Centaur continuing to make good progress right down the middle of the corridor. Current altitude 160 miles, downrange position 2,161 miles, current velocity 16,466 miles per hour. All Centaur systems are within expected parameters. Engine performance continues to look very good.
Losing our signal now through Antigua. Data will be coming through Tidris East.
And we have IIP vanish. Centaur is now orbital. Main engine performance continues to look very good. Chamber pressures are within parameter. LOX pump discharge and fuel venturi are operating as expected for the set mixture ratio. Three minutes to MECO.
Total burn from liftoff at that point will be 18 minutes, 13 seconds.
Storage bottle pressures are stable at this point in the burn. Bus and battery voltages look good. Controlling right down the middle in terms of attitude. Current altitude is 128 miles, downrange position 2,800 miles. Velocity is 18,951 miles per hour. 2 minutes to MECO. All systems continue to operate well. Range track shows the vehicle making good progress. And Centaur has entered the PU limiting phase. Ensure the set MR is within the expected limits. Chamber pressures continue to be stable. LOX pump discharged, fuel venturi, and turbine temperatures are within parameter for the set mixture ratio, which is very close to nominal. One minute to expected MECO. All Centaur systems continue to look excellent at this point in the burn. And we have MECO. Engine shutdown looks good. 4S settling is in progress. Propellant tanks are being vented as expected. Bus and battery voltage are stable. Helium storage bottle is as well. Centaur has begun the turn to the PTC attitude. Has also begun spinning up to 1.8 degrees per second. This ghost period is expected to be just over 82 minutes in duration prior to our second burn, which will be just under a minute in duration.
Right now we're going to look at some of the replays from the different camera angles from the liftoff and from some of the tracking cameras on Cape Canaveral Air Force Station and downrange. .3 kilometers from the expected orbit. Inclination is 4 balls, 3 negative. And all in all, looks to be an excellent orbit. We're now 36 minutes, 30 seconds into the flight of the Atlas V with TDRS K, coming up on acquisition through the tracking station at Diego Garcia in the Indian Ocean. The Air This is Atlas Launch Control. 1 hour 32 minutes 10 seconds into the flight of the Atlas V with TDRS K. The vehicle is now within sight of the tracking station at Guam, and the second burn is coming up very shortly. The Centaur right now is reorienting itself and doing some preparations of this onboard systems for that second burn, which is very brief, only about 1 minute and 59 seconds, after which we will have spacecraft separation. And that occurs at 1 hour 46 minutes 1 second after the liftoff. So at this time, we'll be rejoining Marty Malinowski in the telemetry lab. During the 2-minute engine firing, we'll be getting data from Guam, from Diego Garcia, and from the Indian Ocean TDRS, over the Indian Ocean TDRS Z. So 3 sources of data coming up to give us data on the burn and spacecraft separation. So right now let's join Marty Malinowski once again in the telemetry lab.
With 5 minutes remaining before MES 2, Centaur continues its turn to MES 2 attitude. It continues its PTC roll at plus 1.8 degrees per second. Settling continues in preparation for start. All other systems look good at this time. And Centaur has begun the D-spin from its PTC roll, and we'll try and optimize telemetry. Four minutes to MECO, or MES.
We're at 1 hour 37 minutes into the mission. The Centaur restart occurs at 1 hour 40 minutes 17 seconds into flight. As we can see, the Centaur is reorienting.
D-spin. It continues its turn to the MS2 attitude. And Centaur has completed the turn to MS2 attitude. Two minutes to mess.
Mess is main engine start.
Centaur tank pressurization is underway. Signatures look good. One minute to mess. Burn duration expected to be just under 1 minute. Dual branch pressurization is underway. We have pre-start. We have oxidizer pre-start. We have ignition and full thrust on the RL-10. Chamber pressures look to be within band. Centaur PU has been set to nominal mixed ratios. Currently accelerating at 1.3 Gs. PU is now operating fuel rich. Chamber pressures, LOX pump discharge, and fuel venturi are responding as expected. Main engine performance continues to look very good. Seeing some thermal conditioning firings on the RCS, and we have MECO. Engine shutdown looks good. We'll now coast for 286 seconds prior to spacecraft set. Fuel tank pressures are venting down. Storage bottle pressures are stable. Bus and battery voltages look good. Centaur has begun reorienting to spacecraft separation attitude. Centaur RCS is now settling at a 50% duty cycle. Fuel tank pressures are venting as expected. Quick check of the orbit show the apogee height to be 2.3 kilometers above nominal. Inclination is minus 4·7. Centaur has completed the turn to spacecraft separation attitude. Continuing to settle at a 50% duty cycle. And Centaur has begun its spin up. Centaur will spin up to 30 degrees per second prior to spacecraft set. Currently spinning at 3 degrees per second. Ten degrees per second. $15 degrees per second. $20 degrees per second. $25 degrees per second. $30 degrees per second, and we have spacecraft separation. Centaur has begun to despin. It will continue to do so and increase settling as it continues on to its collision avoidance maneuver. With that, this concludes tonight's broadcast of the TDRS-K AV-36 mission.
And in just a moment, we'll have our launch director from tonight's flight, Tim Dunn, come over and discuss how the countdown and the launch has gone based on the data that we've received here at the Atlas Space Flight Operations Center. The final burn of the Centaur, lasting just under a minute, appears to have been quite nominal. And so it appears as well that we've had a very successful flight of this particular Atlas Centaur rocket. So that this will set the stage for our next Atlas for NASA, which will be coming up very shortly, in about a week's time. Or slightly more than that, slightly less than 2 weeks. And we'll let Tim tell us about that one. Lots of handshakes from the United Launch Alliance team, as well as the NASA team from the Goddard Space Flight Center, from Boeing, and from the Launch Services Program based here at Kennedy. And they're beginning to configure at White Sands to receive the initial data from TDRS. The first data from the satellite on its own will come through the Dangara tracking station in Western Australia. This is Atlas Launch Control, 1 hour 50 minutes into the flight of the TDRS-K satellite. And joining us here at the console in the Atlas Space Flight Operations Center is Tim Dunn, our NASA Launch Director for tonight's flight. And Tim, first of all, on the surface of it, it looks like we have a happy satellite in orbit.
George, thank you for having me. Yes, indeed, we have a successful spacecraft separation. We just confirmed that via telemetry. So you might have overheard the LCC reacting and the Mission Director Center. There's a lot of happy folks out there, and we've got a customer that's quite thrilled right now to have a healthy satellite on orbit.
Take us through the countdown a little bit from when we first picked up with our coverage tonight and some of the things that we worked through to get us to a successful launch tonight.
Okay, be glad to, George. We picked up the count on time this afternoon. We obviously knew we had some weather concerns that I'll go into a little bit. Coming into the count, we had a nice clean rocket. Range was very clean as well. And spacecraft, we were working no issues. So when we were coming down through the count, getting ready for cryo-tanking decision, the primary concern we had was with weather. Fortunately for us, the predicted weather that we thought we were going to be dealing with was an encroaching thunderstorm activity and a potential for a Phase 2 lightning advisory, which would have had an impact on tonight's launch attempt. That front stayed well to the north, didn't have to deal with that, but in its place we had ground winds that were right on the borderline of acceptability from a structural concern for cryo-tanking of the Centaur. So we spent a little bit of time. We needed about an extra 10 minutes prior to our nominal, compared to our nominal polling time.
I asked Launch Director for that. Our team was able to then analyze the additional data that came in. Simultaneously with that, we worked a launch vehicle issue on the Atlas V. Turned out there was a HAZ-gas sensor, one of a few in the interstage assembly, that had failed. So we had an anomaly discussion. We were concerned about the structural impact of ground winds that were borderline. And that's why we needed just a little bit of extra time prior to going into cryogenic tanking before we were able to complete our poll. Once we worked through that, we got into a nominal timeline. We were headed toward T0 at the front end of the window. We worked just a couple of minor launch vehicle issues during cryo tanking. We had a first stage booster liquid oxygen fill and drain valve that did not give us the appropriate talkback signal, but we have a contingency plan where we're able to use pressure data to tell if that fill and drain valve is opening and closing and cycling as planned. So we were able to work through that. A little bit later in the count, we had another sensor on the vehicle. Fortunately, was triply redundant. It was a pressure sensor that had given us a little bit of noisy data, so we worked through that as well. During that whole time, spacecraft, the TDRS-K spacecraft, was being turned on, rock solid, no problems at all. On the range side, the range had just a few minor issues that they were working. One of the camera sites temporarily went down, came back operational. One of the winds, Doppler radar profilers went down, went non-mission capable, but the range addressed that quickly and was able to bring that back online. And then one of their upper level winds displays was non-operational. We had redundant capability there, but again, the range team, being a great team that they are, was able to bring that component back as well. So once we got down within a half hour of launch, we were clean and green. Everything looked great, and we went right on the first opening of the window at 8:48 p.m. Eastern Time, and very thrilled with that.
Well, Tim, this was a very short turnaround for United Launch Alliance to get to this point, and it's pretty short to the next one, isn't it?
Yes, it's quite short. It's going to be a quick turnaround for our team. We're going to get a little bit of rest tonight, come back in, start reviewing the data from this mission, the TDRS-K mission, and then get most of our team deployed out to Vandenberg Air Force Base in California for the LDCM mission, the Landsat Data Continuity Mission, which is currently scheduled on Atlas V from Vandenberg on the 11th of February.
Well, Tim, it's been a very intense month here, and with the LDCM coming up as well, I think we can say we've had a very successful Atlas launch campaign here in the last month or so, leading through this flight all the way up to LDCM, and I think the team, I'm sure you think, must feel they've done a very admirable job to get us through these two launches this close together.
Boy, yeah, I'm just thrilled with our team, George. We have just an incredibly competent team, just exceptional dedication that they have. Both the NASA government team working alongside our colleagues at United Launch Alliance, we just have one of the finest launch teams assembled, and I couldn't be more proud of them. So George, on a personal note, I would like to make a comment about this launch. I would like to, as launch director for TDRS-K, I'd like to make a personal dedication of this launch to a special little girl, Delaney Graylick. She's a little 14-year-old girl. She's battling cystic fibrosis. She's over in Orlando at Arnold Palmer Hospital. And I just wanted to say, Delaney, this launch was for you. So we're really thinking about you and praying for you.
Well, Tim, thanks very much, and we'll look forward to seeing you and Omar Baez as well out at Vandenberg, and we're all on a plane out of here very shortly.
Very shortly. So, looking forward to it, George.
And that will conclude our coverage of tonight's Atlas V launch with the TDRS-K tracking and data relay satellite. From the Atlas Spaceflight Operations Center at Cape Canaveral Air Force Station, this is Atlas Launch Control. 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And liftoff of the Atlas V rocket with TDRS-K, broadening, enhancing, and improving the capability of space-based tracking.
Roll program has begun. Body rates look good. Plus and battery voltages are stable. Booster engine continues to operate well. Pump speeds are within parameters. Boost pump pressures are good.
Status check.
Go Atlas.
Understood. Centaur. Go Teachers K.
Five, 4, 3, 2, 1. 0, and liftoff of the Atlas V rocket with TDRS-K, broadening, enhancing, and improving the capability of space-based tracking. Three, 2, 1, 0. And liftoff of the Atlas V rocket with TDRS-K, broadening, enhancing, and improving the capability of space-based tracking.
The rocket carrying NASA's new Advanced Communications Satellite, TDRS-K, successfully lifted off Wednesday from the Cape Canaveral Air Force Station in Florida.
Roll program has begun. Body rates look good.
From its geosynchronous orbit, TDRS-K will have a wide enough view of our planet to pick up and relay signals from NASA's fleet of Earth-orbiting spacecraft, including the International Space Station and the Hubble Space Telescope. TDRS-K is the first of a new generation of comm satellites meant to meet the increased demands of NASA's growing fleet of research satellites.
Booster has throttled back, right on schedule.
TDRS-K is the 11th satellite in the TDRS series launched by NASA since it began building the spaceborne network in 1983. 2 additional TDRS spacecraft will follow in 2014 and 2015. The robotic refueling mission wrapped up 4 of its 6 days of testing of robotic technology on the International Space Station. Engineers at the Goddard Space Flight Center and operators at the Johnson Space Center successfully maneuvered Dexter, the station's robotic arm, to its target, a fuel valve on a specially designed practice box. NASA developed tools precisely cut 3 separate wires and removed and safely stowed 2 unique caps in preparation for the main event, the transfer of simulated fuel. This would be a first-of-its-kind robotic fluid transfer on orbit. With RRM, NASA is proving technology that'll help us understand how we can one day use robots to refuel satellites in space, especially those that were never designed to be serviced. Additional tests of this technology will continue throughout the year. NASA engineers working on the nation's new space launch system have resurrected the world's most powerful rocket engine ever flown, the mighty F-1, and test-fired its gas generator on the Marshall Space Flight Center's test stand. What they learned will help engineers develop NASA's new heavy-lift rocket due to launch Orion and its astronauts into space.
If we understand how the gas generator works that was designed in the 50s and the 60s, how did it operate, what are the characteristics of that engine, then we have reduced the risk of understanding how can we then bring it into an advanced booster engine.
The F-1 powered the Saturn V rocket that sent Apollo astronauts to the moon. This 22nd test is one in a series pushing the F-1 gas generator to limits beyond Apollo-era tests. President Obama's proposal for a new national network for manufacturing innovation brought some 350 representatives from industry, academia, and economic development agencies to a NASA co-sponsored workshop in Huntsville. The Blueprint for Action public workshop was a forum at which the network's proposed design could be reviewed and refined. The Marshall Space Flight Center will be home to one of the network's regional components, the Institutes for Manufacturing Innovation.
Manufacturing innovation and advanced manufacturing technology is critical to NASA. It's critical to all of our missions. It's critical to our science missions. It's critical to our human spaceflight missions, our aeronautics missions, and our space technology mission directorate technology that we produce.
Marshall Center Director Patrick Scheuerman served as NASA's representative to the workshop's Interagency Working Group. NASA's Space Technology Mission Directorate leads the agency's participation in the nationwide Advanced Manufacturing Network. A NASA suborbital telescope has given scientists the first clear evidence of energy transfer from the sun's magnetic field to the solar atmosphere, or corona. This process, called solar braiding, has been theorized yet unobserved by researchers until the high-resolution coronal imager, HI-C, obtained highest-resolution images from a large, active region in the sun's corona. Launched from the White Sands Missile Range in New Mexico last July, the 464-pound, 10-foot-long HI-C telescope took 165 images during its roughly 10-minute flight. Initial image sequences were seen to demonstrate the evolution of the magnetic field and its repeated release of energy through activity seen on the sun at temperatures ranging from 2 million to 4 million degrees. While the Mars rover Curiosity may be grabbing its share of headlines these days, another Red Planet rover is quietly embarking on its 10th year of exploration. Opportunity is smaller and doesn't carry the same high-tech tools as Curiosity, but since landing on Mars on January 25, 2004, it's made many notable discoveries, including the Red Planet's warmer and wetter past. Opportunity and its twin, Spirit, were only supposed to explore for 3 months, but both outlasted their original mission. Spirit lost communication with Earth in 2010, shortly after getting stuck in Martian sand. But Opportunity remains healthy and studying interesting rocks in a massive crater. Another NASA spacecraft, this one orbiting Mars, is providing new evidence of a wet underground environment that adds to an increasingly complex picture of the planet's early evolution. Researchers analyzing spectrometer data captured by the Mars Reconnaissance Orbiter, MRO, of the floor of McLaughlin Crater think the 1.4-mile deep crater once allowed underground water, which otherwise would have stayed hidden, to flow into the crater's interior. Layered, flat rocks found at the bottom of the crater contain carbonate and clay minerals that form in the presence of water. McLaughlin also lacks large inflow channels, and small channels originating within the crater wall end near a level that could have marked the surface of a lake. Launched in 2005, MRO and its 6 instruments have provided more high-resolution data about the red planet than all other Mars orbiters combined.
NASA scientists routinely use lasers to track the position of the Lunar Reconnaissance Orbiter's laser altimeter as it orbits the Moon. Recently, however, they also tried something a little different. In addition to tracking the instrument, they used the laser to send a picture of the famous Mona Lisa in the first demonstration of laser communication with a satellite at the Moon. To do this, the LRO team used the existing laser tracking signal sent by the Next Generation Satellite Laser Ranging Station at NASA's Goddard Space Flight Center. The image was divided into pixels, which were then sent to the spacecraft one at a time by retiming the regular tracking pulses. By delaying the tracking pulses by specific amounts, LRO scientists could use the difference between the expected arrival time and the actual arrival time to indicate the brightness of an individual pixel. Once the image was sent, scientists corrected for transmission errors caused by the Earth's atmosphere using common techniques used in CDs and DVDs. They also studied signal fluctuations due to Earth's atmosphere. The final image was verified when it was returned to Earth using LRO's radio telemetry system. This test, and the data obtained from it, sets the stage for future high data rate laser communication demonstrations that will be a central feature of NASA's next moon mission, the Lunar Atmosphere and Dust Environment Explorer. So, while lasers are currently being used to track NASA satellites, in the future they may also be used to communicate with them, sending not only data, but perhaps images that one day will be as famous as the Mona Lisa.
I do want to welcome all of you here for what I hope will be a very inspiring program.
NASA Administrator Charles Bolden kicked off a special commemoration at headquarters of the life and vision of Dr. Martin Luther King Jr. The MLK Day of Remembrance program featured musical selections, poetry, and speakers celebrating the continuing impact of Dr. King's work and philosophy.
People all over the country, including Dr. King, were very important in the civil rights movement.
The NASA headquarters chapter of Blacks in Government, BIG, sponsored the event.
Liftoff. We have liftoff with Apollo 14.
42 years ago, on January 31st, 1971, the Apollo 14 mission began with the launch of the Saturn V rocket from the Kennedy Space Center. Astronauts Alan Shepard, Stuart Roosa, and Edgar Mitchell manned NASA's third mission to land on the Moon.
It looks like you're about on the bottom step and on the surface. Not bad for an old man.
Shepard and Mitchell conducted 2 lunar EVAs and collected more material and scientific data than Apollo 11 and 12 combined. And famously, Commander Shepard swung the first golf club in space, sending 2 balls across the lunar frontier.
Miles and miles and miles.
Apollo 14 touched down safely in the Pacific Ocean on February 9, 1971. This commemorative plaque was issued to the United States and the governments of 14 other countries to mark the signing of the Space Station Intergovernmental Agreement 15 years ago on January 29, 1998. The IGA is an element of the legal structure used to regulate the International Space Station and is an agreement between NASA, the Canadian Space Agency, the Japan Aerospace Exploration Agency, the Russian Federal Space Agency, and 11 member states of the European Space Agency.
Good day and welcome to Mission Control Houston, where a multidisciplinary team of flight controllers is watching over the systems aboard the International Space Station as the Expedition 34 crew continues its work. Today the crew has assembled Robonaut for another set of on-orbit tests that are looking at what kind of an assistant a humanoid Robonaut might be for humans in space. They're also doing ultrasound background noise testing to continue work started earlier in the week to characterize the sound levels on the station, and replacing the manifold bottle on the combustion integrated rack, which allows flame experiments to go on aboard the International Outpost. Ford and Hadfield were the prime crew members working with Robonaut, taking the humanoid Robonaut out of its sleeping compartment and setting up a task board for upcoming remote commanding. Meanwhile, engineers on the ground today work with new software that could allow Robonaut to be controlled by virtual reality gear on the orbit in the future. And it was Ford who also worked with those ultrasound measurements. Tom Marshburn, meanwhile, worked on updates to the automated payload switch upgrade that will help facilitate remotely controlled research on the International Space Station. Novitsky, Torelkin, and Romanenko did a variety of experiments as well as station maintenance tasks. Novitsky did air filter cleaning. Torelkin worked on water purification and filtration maintenance in the Rushman segments of the station. And Romanenko installed experiment hardware for the Kristall experiment. Later on today, ground controllers will be stowing the Dexter Special Purpose Dexterous Manipulator, which has been on the end of Canadarm2 for the past 2 weeks. Last week for remote refueling mission activities, looking at how we might use robotic spacecraft to go refuel spacecraft that never were designed to be refueled in orbit. All those tests went very well, a combined project of the Goddard Space Flight Center of NASA up in Maryland and the Canadian Space Agency. Flight controllers here in Mission Control and at the Canadian Space Agency's robotic support facility in St. Hubert, Canada, worked together on those remote controlled activities. They also, earlier in this work, moved around a couple of different orbital replacement units on the outside of the space station, moving them from one rack to another and putting them in the right position so that the degraded components are out of the way and that the components that may be needed soon for upcoming replacement tasks are right at hand. Today, the crew on the ground is going to use the robotic arm to stow the Dexter manipulator on the mobile base system. Meanwhile, at the Baikonur Cosmodrome in Kazakhstan, the work is continuing to prepare for the next Russian cargo craft, Progress 50, for a launch on February 11 to the space station. Ahead of that, the Progress 48 spacecraft, which arrived at the station in August, will be undocking from the Pirs docking compartment. That is coming up on Saturday, February the 9th at 7:15 a.m. Central Time. We'll have live coverage of that on NASA TV. And after that, it'll be deorbited 3 hours later, so it burns up into the atmosphere and plunges to a destructive demise in the Pacific Ocean. And that'll clear Pirs for the accelerated single-day launch to docking of a Progress 50 on Monday, February the 11th. Launch from Site 1 launch pad where Yuri Gagarin launched at Baikonur is scheduled for 8:41 a.m. Central Time on February the 11th. And then 4 orbits later, it'll be docking to the space station at 2:40 p.m. Central Time. A New Progress is going to be carrying 1,700 pounds of propellant, more than 100 pounds of oxygen and air, more than 900 pounds of water, and some 3,000 pounds of spare parts, experiment hardware, and logistical equipment, total of almost 3 tons of supplies in all. And that single-day launch to docking is in preparation for potential use of that single-day launch to docking for humans to minimize the stress on crew members as they head up to the International Space Station. Space Station managers and partners met this morning to review all the preparations for the undocking of 48 Progress and the launch of Progress 50, and so far no issues have been identified, and we're looking forward to that coming up later this month.
Der Bundestag hat das Mandat für den Afghanistan-Einsatz verlängert um etwas mehr als ein Jahr. Dafür gab es eine breite Mehrheit. Gegenstimmen kamen vor allem von der Linksfraktion und von den Grünen. Im Laufe des Jahres soll die Truppenstärke um ein Viertel verringert werden auf 3.300. Ende 2014 sollen alle Kampftruppen abgezogen sein. Dann bleibt nur noch eine Ausbildungsmission in Afghanistan. Auch mit dem Bundeswehreinsatz in Mali muss sich möglicherweise bald der Bundestag befassen. Bislang leistet die Bundeswehr nur logistische Unterstützung mit 3 Transall-Flugzeugen. Darüber musste das Parlament nicht abstimmen. Jetzt hat Frankreich aber um Hilfe bei der Betankung von Kampfjets in der Luft gebeten. Damit würde die Bundeswehr so eng in den Einsatz eingebunden, dass auch nach Einschätzung des Verteidigungsministeriums ein Mandat des Bundestages nötig wäre.
Kein einfaches Manöver. Ein Kampfjet wird bei 500 Kilometern pro Stunde in der Luft betankt. So könnte Deutschlands nächste Hilfe aussehen. Deutsche Großtanker sollen französische Kampfjets mit Kerosin versorgen, die auf dem Weg nach Mali sind. So jedenfalls sehen die Pläne des Verteidigungsministers aus. Kommentieren will er sie nicht, doch von Unionsseite werden sie begrüßt.
geht hier darum, zusätzliche Leistungen zur Verfügung zu stellen, um unserem Partner Frankreich in der Absicht zu helfen, zu verhindern, dass in Mali eine Keimzelle für internationalen Terrorismus entstehen kann.
Deutschland hat bereits 2 Transall zur Verfügung gestellt, zum Truppentransport von afrikanischen Soldaten. Eine dritte steht bereit. Über weitere Hilfe soll aber das Parlament abstimmen. Für die Grünen ist die Zustimmung nicht selbstverständlich.
Das Entscheidende an dem Militäreinsatz ist ja, dass er jetzt übergeht, ja, in einen geordneten politischen Prozess. Denn Militär kann nie die Lösung des Problems bringen.
Zustimmen soll das Parlament auch einer geplanten EU-Ausbildungsmission für Mali. Beim Treffen mit seinen Amtskollegen macht Bundesaußenminister Westerwelle deutlich, wie wichtig dies sei.
Die beste Entlastung Frankreichs ist es jetzt, die afrikanischen Truppen zu befähigen, ihre Verantwortung im Norden Malis nachkommen zu können.
Das EU-Ausbildungsmandat und die Luftbetankung. Beide Einsätze könnten im März vom Parlament beschlossen werden.
Ein israelischer Luftangriff im Nachbarland Syrien verschärft die Spannungen im Nahen Osten. Aus Syrien heißt es, dass Kampfjets ein militärisches Forschungszentrum zerstört hätten. Westliche Sicherheitskreise berichten dagegen, dass ein Fahrzeugkonvoi mit Flugabwehrraketen angegriffen worden sei. Dieser sollte die Waffen angeblich zu Hisbollah-Milizen in den Libanon bringen. Syrien droht Israel nun mit Vergeltung. Und auch Iran, Syriens Verbündeter, warnt, der Angriff werde Folgen haben.
Aufmacher heute in allen israelischen Hauptnachrichten: der Angriff auf Ziele in Syrien. Doch Einzelheiten dürfen wegen der Militärzensur nicht genannt werden. Die instabile Lage in Syrien wird in Israel immer mehr als Bedrohung empfunden. In Haifa und auch weiter im Norden werden Raketenabwehrsysteme in Stellung gebracht. Die Grenze zu Syrien wird weiter verstärkt. In Syrien tobt ein Bürgerkrieg. Es gibt eine Menge bewaffneter Milizen. Syrien ist kein Staat mehr, es ist gefährliches Niemandsland. Um zu verhindern, dass chemische oder konventionelle Waffen der geschwächten syrischen Armee in die Hände der radikal-islamischen Hisbollah gelangen, haben offenbar israelische Kampfflugzeuge Ziele in Syrien angegriffen. Syrien bestreitet erneut Waffenlieferungen an die Hisbollah und droht Israel mit Vergeltung. Die Regierung heizt die Stimmung an. Die wollen alles zerstören und uns umbringen. Meiner Meinung nach müssen wir reagieren. Auch Russland, neben dem Iran der letzte Verbündete der syrischen Regierung, ist besorgt, fürchtet eine Eskalation. Das muss vor den UN-Sicherheitsrat. Es ist klar, dass hier eine Verletzung des internationalen Rechtes vorliegt. Wie üblich schweigt die israelische Führung zu militärischen Operationen, dementiert diese aber auch nicht. Bereits am Wochenende hatte Premier Netanyahu angekündigt, ein verändertes Kräftegleichgewicht in der Region nicht hinzunehmen.
Der Europäische Gerichtshof hat die Rechte von Flugreisenden gestärkt. Werden Flüge wegen Naturkatastrophen gestrichen, müssen die Airlines die Passagiere betreuen, bis eine Heimreise möglich ist. Geklagt hatte eine Frau, die 2010 für eine Woche in Portugal gestrandet war. Damals wurden nach einem Vulkanausbruch in Island weite Teile des europäischen Luftraums gesperrt. Der Billigflieger Ryanair weigerte sich, die Kundin in einem Hotel unterzubringen, wegen außergewöhnlicher Umstände. Nach dem Urteil muss die Fluggesellschaft nun 1.130 € Unterbringungskosten erstatten.
Regen dürften Sie gewohnt sein. Die Menschen in einem kleinen Fischerstädtchen an der englischen Ostküste. Doch was dort jetzt vom Himmel kam, war selbst für die hartgesottenen Einwohner der blanke Horror. Es regnete menschliche Überreste. Genauer gesagt Knochen aus jahrhundertealten Gräbern. Der Tatort Whitby befindet sich in der Grafschaft Yorkshire, direkt an einer berühmten Kirche, der St. Mary's Church. Und die liegt mit ihrem Friedhof an einem Hang, der nun nach und nach abzubröckeln beginnt. Und wäre das nicht schon gruselig genug? Jetzt werden Sie von meiner Kollegin Annette Dittert auch noch erfahren, wer an diesem Leichenschauer schuld ist. Dracula.
Es war ein dunkler, stürmischer Wintertag, als das Geisterschiff anlegte im Hafen von Whitby. Auf dem Friedhof hinter der Kathedrale sahen Fischer wenig später einen schwarzen Hund, der zwischen den Gräbern verschwand. So betrat Dracula die Insel in Bram Stokers Roman, auf der er fortan von hier aus sein Unwesen trieb. Und bis heute lebt die kleine Hafenstadt von diesem Mythos. Vor allem aber lebt davon Harry, der Dracula Tourguide.
Viele tausend Menschen kommen jedes Jahr hierher,
Um auf seinen Spuren zu wandeln. Sie wollen die 199 Stufen hoch zum Friedhof gehen, so wie er damals, und suchen dann nach seinem Grab, das es aber natürlich nicht gibt. Denn Dracula wurde schließlich am Ende in Transsilvanien vernichtet und nicht hier an der englischen Ostküste. Jetzt aber ist etwas passiert, das dem Vampirtourismus wieder neuen Auftrieb geben wird. Die Gräber haben sich geöffnet. Zwar nicht direkt durch Draculas Hand, sondern ganz simpel durch Küstenerosion. Der Priester geht mit dem Spuk pragmatisch um. Regelmäßig klopft jetzt jemand bei mir an die Tür des Pfarrhauses und hat eine Plastiktüte mit Knochen oder einem Totenkopf in der Hand. Was wir dann machen? Wir graben sie wieder ein. Weniger gelassen nehmen das die direkt unter dem Friedhof leben. David zum Beispiel, der erst gestern hinter seinem Fischladen menschliche Hüftknochen gefunden hat. Das abrutschende Cliff aber bedroht auch sein Haus. Das ist schon ziemlich traurig alles, schockierend. Und wir hoffen jetzt nur, dass demnächst nicht noch der ganze Friedhof runterkommt. Der Gruselfaktor Whitbys steigt aber ganz eindeutig hiermit. Und der Vampirtourismus dürfte auch zunehmen. Das hofft jedenfalls Harry, der Dracula-Tourguide, den die offenen Gräber durchaus inspirieren. Sind das Draculas Knochen? Nein. Sind es menschliche Knochen? Ja. Das verdichtet die Atmosphäre schon sehr. Während die Touristen bis jetzt vor allem wegen der Kirche kamen, werden wir jetzt eine neue Sorte ansprechen, die von der dunkleren Seite. Und so sorgt der Friedhof am Cliff, der schon Bram Stoker zu Dracula angeregt hatte, heute für Touristenströme statt Totentanz.
Whitby, die Stadt, in der es Knochen regnet. Sven Plöger, diesen Satz werden wir hoffentlich nie von Ihnen hören.
Also Karen, wenn ich Ihnen was versprechen kann, dann ist das jetzt in die Hand versprochen. Regnende Knochen, das wird nicht mein Thema sein. Aber Regen, das werde ich zum morgigen 1. Februar relativ häufig gleich in den Mund nehmen im Wetterbericht. Das kann ich jetzt schon versichern. Aber zunächst mal spreche ich über wenig Sonnenschein. Der Januar ist zu Ende gegangen, der Januar 2013. Und viele von Ihnen haben es irgendwie gemerkt, die Sonne war praktisch gar nicht da. Und wenn man das hier mal auswertet, sieht man ganz im Norden, ganz im Süden über 35 Stunden. Das klingt ja schon wenig. Aber es gibt einige Regionen mit weniger als 15 Sonnenscheinstunden und Blankenrath in Rheinland-Pfalz. Eine ganz schöne Gegend, aber leider im Moment etwas sonnenunverwöhnt. 5 Stunden 45 im Januar 2013. Also selbst ein Januartag, der den ganzen Tag sonnig ist, bringt knapp 8 Stunden zustande. Und die Zugspitze, Deutschlands höchster Berg, der wurde einigermaßen vernünftig versorgt. Und wir haben noch mal für Bielefeld als Beispiel ausgewertet. Hier, Januar 2013, 10,5 Sonnenstunden. Und das ist gerade mal ein Fünftel dessen, was ein durchschnittlicher Januar, und der ist normalerweise nicht sonderlich sonnenscheinreich, so zustande bringt. Weg von der Sonne hin zum neuen Regen und dem neuen Tief. Der Strömungsfilm zeigt, Westwind nicht mehr so stark. Der Wind lässt etwas nach, dann kommt neuer Wind auf. Das liegt an dem kleinen Tief, was uns überquert. Und was eben für den neuen Regen sorgt. Ein bisschen Sonne im Osten, vor allen Dingen am Sonntag. Hamburg 15 Tage Trend. Es wird noch mal warm zum Montag. Dann kommt aber nachhaltig ein bisschen Kälte. Der morgige Tag schriftlich zusammengefasst. Also so wie der Januar endete, startet auch der Februar. Wenig Sonne und viel Regen, Karin.
Trotzdem danke, Sven Plöger. Und wir sagen Tschüss, bis morgen.